Hello, and welcome to this new webinar from Circontech. I'm Marcelo. Today, our CTO Will is here to present on application modernization with AWS Refactor Spaces. Well, that's a mouthful. Without further ado, I hand it over to Will to take it away.
Thank you, Marte. Welcome, everyone. So let's first try to give some context to this long title that we have in front of us. I'd like you to imagine that you receive a legacy application that was originally developed as a big monolith, meaning that all of its services and components were created under a single system, and that we have a few requirements to accomplish. One of them is to modernize this application. And the other requirement for us is to transform it into a microservices version, right? So now let's define this idea of modernization. We will say that modernization is a process of migrating and transforming an application and its architecture to take the benefits of cloud computing. And what are these benefits on cloud computing? It's mainly referring to all of those practices that will allow us to reduce our efforts around operations, and instead will allow us to focus on developing new functionalities. In other words, it's taking the advantage of serverless computing, where we can empower activities such as managing self-managed servers and databases, but also design modern pipelines and create release cycles that allow us to decide when we want to publish new applications, how we want to test our apps, and so on. But also we can also check the way we are managing licenses. If it's the case that we are having high costs on Windows servers or maybe SQL Server, we can decide to use virtual machines on the cloud and have that savings on costs. So
Sorry, Will.
another,
Yeah. So can you just, so it's clear for the audience, can you give an example of how using a managed database, for example, a service from AWS, might simplify operations compared to self-hosting?
Yeah, absolutely. So imagine that you are developing an application either on premises or in the cloud, but in a simple manner. So for instance, you will create an EC2 application where you install your packages, and maybe you install your own database for, let's imagine, Postgres. In that case, you need to worry about managing all of those things that come with that database. That means, for instance, taking snapshots, perhaps worrying about data replication, partition, having the ability to upgrade that database, and perhaps also make it fault tolerant and encrypt data. So if we decide to use services such as RDS or even Dynamo, we will be all that for us handled on the cloud, right? So in that situation, we take the full benefits of the serverless computing and the built-in services from the cloud. So another example is having managed analytics and data lakes that will allow us to design modern pipelines where we can work around our data. We can clean it and create maybe machine learning processes in a very fast and also serverless computing manner. Another big benefit is around building applications that are resilient and highly available. And that means taking full benefits from the cloud different regions, right? So we can create fault-tolerant solutions that even in case of failure, will be getting the best for our users. We can also take our apps close to the users geographically, so that is also another big benefit. So what we get after doing all of this is to minimize what's called the total cost of ownership, which is a metric that can be calculated as the sum of paying for certain hardware plus the cost of maintaining it. So if we can dedicate our efforts into produce new features, we will at the end be getting a return of investment translated into value for our software rather than spending time on managing these set of things. So why do we want to move from monoliths to microservices, which was the other requirement that we proposed? Basically, I think that monoliths still work great in many scenarios. They are probably the right answer for scenarios where our scope is small, or maybe our team of development is also small. And in that case, it will be cumbersome if we try to create a system that is very hard to manage for very few people. But as soon as our system grows, we perhaps want to decouple that system and isolate responsibilities. So ideally, we will identify domains within our system, so we can identify, for instance, maybe a reports section or a machine learning section that we can separate and treat those as individual services. So we get quite a few benefits by doing that. We can achieve independency on the way we test those microservices. We can have separate monitoring, but we can also scale them individually. So moving forward, the question we ask ourselves, probably from now till the end of the presentation, is how can we migrate from a monolith version into microservices? And the answer that we will be sharing today is through a pattern called Strangler Fig. This pattern was originally proposed in the early 2000s by Martin Fowler, and it gives its name in a nature activity, actually. So the Strangler Fig is a tree that grows in the tropical areas, and it starts growing as a branch around another tree. And over time, it starts consuming its resources, so it's kind of a parasite. And as the time goes, another branch grows and another, until with enough time, only the Strangler Fig will prevail, right? So the inner tree dies. And this clearly describes what we want to achieve with this transformation. In our case, the microservices will be the Strangler Fig, and the host tree will be the monolith, right? So we are trying to make both to be part of a solution over time. So why do we want to use this pattern? Let's take a step back and think about what we will do traditionally. Traditionally, we can think of a more big bang strategy, where is that we develop the whole set of microservices. We set a date or switch those systems, and then we just cross our fingers and hope for the best. But that certainly has a lot of operational risk, and it's not ideal, right? So, and also we maybe keep developing our monolith application, so we need our microservices to keep up, right? So it is better if we create our new system incrementally, right? So we can perform frequent releases as soon as our microservices are being completed, right? So the way we want to achieve this through the cloud is using a service called AWS Refactor Spaces. It's not a very known service, but we will dive into it in a few minutes.
I have a question about this.
Yes.
How do you decide which part of the monolith you take and you migrate first?
Yeah, good question. And that is actually what we will be talking about in a second. But mainly, you will decide primarily for your business reasons, right? For your interests around what has more priority for your solution. Maybe you have a service that is causing maybe high costs, or perhaps it's causing conflicts for your developers for the way the release happens. So in that situation, you will decide based on how valuable is that service for your business, right? It's not so much a technical decision. Technically, you can just migrate it in any order, right? So I guess it comes with that business part attached.
Excellent.
So let's discuss a little bit about this pattern, right? So let's put an example. Imagine that we have a blog application, very simple monolith with a few services that is composed of a user service, a post service, and a thread service. The middle arrow represents that the thread service is using some functionality from the post service. So the first thing we do, according to the pattern, is to add a proxy component. And this proxy is what will allow us to route traffic between the monolith and the microservices. And initially, the proxy, all it does is just to redirect everything into the monolith, right? But we can also take another small step where we add a new microservice that, let's think of it as a new functionality. So it was not part of the monolith. We just simply add it to the proxy, and everything else remains the same. But we then start migrating services that were part of the monolith application. In that case, we add it to the proxy, and we tell the proxy to stop sending traffic to that microservice, to that service, and instead send it into the new microservice. So what happens if we now want to migrate something that is more interconnected, right? So if you want to migrate the post service, which other services are depending on? In that case, we need to introduce briefly another small pattern called the anti-corruption layer. And this pattern basically acts as a mediation layer, and it's a class that works as a translation route where it basically allow us to minimize the transformation risk and makes the application backward compatible, right? So this class will be in charge of calling the new service, mapping the response and the interface to be compatible with old versions, and remain the system unchanged in that sense, right? So graphically,
Sorry,
yeah,
about this, using this proxy, is there any performance overhead that you have because you have this new component in the middle? And if so, how can you minimize that impact?
good question. Yeah. So for the proxy component particularly, as any other proxy outside this pattern, the proxy will indeed add some small latency time. I will say around 100, maybe 200 milliseconds to our solution. And it's also a bottleneck to our solution, right? So if our proxy fails, we will be putting in risk the whole migration, right? So it is important this proxy to be a robust component, something that can scale, and ideally to be fault tolerant, right? So we cannot just simply throw a small server running Nginx that will put a lot of risk into the solution. So ideally, we should treat that proxy as an important aspect when we decide the tools that we will be using. So yeah, in terms of latency, it adds that small latency, but we also get a lot of benefits from using the proxy. We can get monitoring at that level. We can also create authentication at that level. So in a certain way, it has its pros and cons. So we were at anti-corruption layer, and graphically, it will look something like this. The ACL is just a simple class that goes within the monolith and allow us to map the responses from the post service and get it back to the threads service in this case. So what happens with the data, right? So that's another fair question that we can ask. And if we want to keep data in sync between maybe the monolith and our new microservices, in that case, we just simply treat it as a traditional data synchronization problem, where we can have a synchronization agent, maybe through events, or perhaps using a queue for fan out, that will allow us to keep both database systems in sync, right? So yeah.
So, and what are some challenges that you can have when you are trying to synchronize the data between the old monolith and the microservices? And how does AWS help us with that? Is there any service that we can use?
Right. So in this case, data synchronization is similar to the proxy issue. It's outside of the pattern and should be treated as with any other situation. And we can have several challenges there. And also, it all depends on how complex and in real time you want our data to be, right? So if we have a lot of traffic or between those databases and we want them to be real time, yes, we will certainly have a challenge there on how to keep those in sync. Also consistency issues, replica issues. So yeah, we can face a lot of challenges. It all depends on the particular issue and scenario that we are treating. But particularly in AWS, we have a service. Traditionally, we will use something like Event Bridge plus EQS, but now we have a database migration service, which is a great orchestrator for this type of problems. It will allow us to sync two schemas, even if they are different. So if we think of this like an RDS, but this is maybe Dynamo, migration service also takes care of those situations. It allows us to map those schemas. We get monitoring, and we'll also do it ongoing, right? So it's not just one-time migration, but it's an ongoing synchronization of databases. But by treating each new microservice as a new release, we can also reduce the costs or the efforts of synchronizing databases, right? So we treat the needs of this microservice along this database status, right? So we can also try to split our problem. So as we move forward, we will reach a point where all of our services were migrated, and we can finally cut the dependency with the monolith. And by then, we will have reached a situation where only the Strangler Fig prevails, right? So let's jump into a quick demo through the console. Let me escape this. Right, and let me share a bit of context for this as well. We have our monolith application following the same example for a blog system. We have simplified to users, posts, and threads, and we want to reach a version that looks something like this, where we have different applications for each one of these domains on our monolith. So we have an application for users, another one for posts, finally another one for threads. So if we translate this to AWS, we can think of something like this. So we have, in this case, a Fargate application running with containers that is responsible for hosting the whole set of features for the monolith. And on top of it, we have an application load balancer that will route the traffic for the entire application. And finally, we have a Route 53 just to simply give it a nice domain. So we can go ahead and check quickly how this API is responding, right? So we have a list of posts. We also have a list of users. And we also have a list of threads. We can also get threads individually. So basically, this API is responsible for the entire set of functionalities of this application. But we want to reach another version where each one of these services are different Fargate applications. So we will have a Fargate application for the users, another one for posts, and another one for the threads. Each one of them will have a load balancer on top of it, taking care of that traffic particularly. So it's easier if we think this like as if it was an API. But yeah, particularly it works with anything that has like a public endpoint that can be reached. And finally, we have our proxy component, in this case, represented by API Gateway, which is fault-tolerant, highly scalable. So it's ideal for this type of architecture. And optionally, we have a network load balancer component that will help us to communicate with private endpoints in case we don't want to expose our microservices publicly, right? So if we create VPC links for all of these applications, we can communicate to the API gateway through the network load balancer. And on top of that, we have our orchestrator, that in this case is the migration refactor spaces that we will see in a minute. Just wanted to show you that these microservices, each one of them has its own URL. So in this case, the user's microservice will reply all from microservice and the user's list, but obviously this microservice does not know anything about posts, for instance, right? So it only takes care about users, right? So we are now ready to jump into the AWS console. And to get here, we look for refactor spaces. And if you see, refactor spaces is a feature within another bigger service called Migration Hub. And if we have time, we will have a quick look at it. And one of the first things you notice in here is that you have a direct access to a Strangler Fig link, which gives you a quick overview of how this pattern works. And I think it's pretty cool because this service is purely dedicated to apply this pattern and nothing else, right? So yeah, it's a nice thing to look at. But in order to accomplish this migration and follow this example, we need to create a few logical things. The first thing we do is to create an environment. An environment, it's what we will use to orchestrate our migration. And ideally, this environment or this migration should happen between 3 different accounts in AWS. That's what AWS recommends. The first account is where we create this refactor spaces application. A second account is where we host our monolithic application. And a third one is where we create our monolith or microservices, right? And the reason for that is so we can ideally keep our resources isolated, but also we can split the bill or have different teams working in the different applications, right? So we can also isolate it in that way. But that's all optional. We can just do it all in a single account. So the first thing we do is to create an environment. We can actually provision a network or a private gateway for communication with other accounts. We won't do it for now. We can check the permissions that this will be using. And the second optional logical thing that we need to create is the application. The application is what will allow us to define which are our services, our monoliths, and our microservices, and the way we want to route them and our traffic to work over time. So we simply give a name, and we choose where we want our proxy component to be created, in which VPC. I have previously created some VPCs, but it can all be done in the default one for testing. And we finally can optionally share this with other accounts or organizations units. We can do it at a later point if we want. And that's pretty much it. With that, we create the basic set of things we need for this migration. And this will take a few minutes, but let me show you what else we need to do. We then need to create a service. And as you can see, this is creating the API gateway and the network load balancer for us. So we don't need to manage that. The next thing we do then is to create our services, right? So the first service we need to register is our monolith. And we also select VPC for it. And we will take the endpoint we're looking at earlier. We can optionally add a health check endpoint. And finally, we can decide if this will be our default route or not. In this case, we do want that. And this will, I anticipate it will fail because it's not ready yet to be created, because the application has not yet been completed its creation. But I previously created another one, which is in a healthy status, right? So I enter this application, and I now have my services defined. I have my monolith service, but I also added a microservices endpoint for our posts, right? So we added a branch to this Strangler Fig. And as you can see, it's also managing by us the API gateway definition, right? So all of this is done for us. I added a custom domain on top of this API gateway so we can see it better from the outside, right? So if we access /users from the final application, we get a response from the monolith because it doesn't say hello from microservices. But if we visit posts, we will get a response from the microservice, right? So we are at the moment combining those two solutions, those two trees. But let's create just one more service for the users. In this case, so we can see it, microservice users. Have this application here. We can select the way we want to reach this API. In this case, /users. We can decide if we want to append information from the source path. In this case, we don't want that. And we can optionally decide which HTTP methods we want this microservice to handle. Perhaps if we are dealing with a GraphQL endpoint, which is one post here, right? But in this case, just for simplification, we will take everything. And we can decide if we want this to be in an active or inactive state, depending if our application is ready or not to be accessed. So we create our users microservice, and this will take a few minutes also to finish deployment, mainly because, yeah, it takes some moments for this to be defined, but also Route 53 needs to update the traffic.
So while this is being created, can you briefly explain how this Refactor Spaces integrates with other migration tools? For example, how does it work alongside this migration hub you mentioned?
Yeah, absolutely. Let's jump into that. So as I was saying, this Refactor Spaces is part of a bigger service called Migration Hub. And this space, which is much bigger, it offers a set of tools and information to help you transform your application and be a companion on your modernization journey. And you get mainly a lot of information, a lot of checklists that you can download, and a lot of help that will help you to assess how ready are you or what you need to accomplish your migration in terms of your technical expertise, your costs, the time you need to wait, and your current workload or your current system, right? So you can plan that in a more safe way, right? So just to dive into quickly some of the things that we have here, we have some tools that are agents that will help you to collect information from your source system. So you install this either in your cloud environment or your on-premises environment, and will gather data to then be published into this dashboard, helping you to get an understanding on what are the types of servers you will need to follow that workload you currently have. And if you have maybe some high peaks at certain hours, you also get information and analysis over your data that will help you decide you need this type of servers or another one. So yeah, it's a pretty powerful and useful tool to have. This is in terms of servers. So you have this discovery of servers. It will also tell you which type of servers you have installed, which type of servers, how they work, how are they connected, and so on. So you get a lot of recommendations around your instances, the instances you will need at the end. You can also quickly visiting this, try to discover your data sources. So you also have collectors for your data that will help you to import information into AWS quickly. We'll also share with you tools and templates that you can use to map different schemas, right? So you get a lot of help and information depending on your use case. But particularly in this scenario, we are dealing with Refactor Spaces, which is simply an entry within this bigger service. So getting back to Refactor Spaces, let's see if our service finish its creation. It seems it hasn't. But yeah, what we want to see is that if we access the /users over here, we should see a response from the microservice the same way as we saw it for the posts, right? So while we wait that for this to finish, hopefully on time, let's take a quick back to the presentation just to do a recap on what we have seen so far. So as a quick recap, we discussed the idea of modernization, all of those processes, the benefits from the cloud and the computing, serverless computing. We also discussed the differences between monoliths and microservices. We then dive into the Strangler Fig pattern to finally reach this service in AWS on how can we achieve this migration. So yeah, I don't know if you have any questions for maybe for the audience or from you, Marcel.
When you're enabling these new microservices, what happens is if something goes wrong, if after activating one microservice it fails or it's not working properly, how easy is to roll back to the monolith?
Yeah, that's a good question. So as soon as we activate one of our routes, so we have here an option to activate or deactivate certain route, we are putting into production or exposed to the world our microservice, and things can go wrong. Yeah, certainly. And in that case, by default, Refactor Spaces will check the health of our application or our microservice, and if things aren't responding correctly, it will roll back to the previous version. So we have that minor canary validation check. But if things fail sometime after, we then need to think on other ways to manage that. We can simply come here and deactivate that, but it won't be done for us in that case. So if we want to plan maybe a blue-green deployment or to partially release a microservice to our users, we then need to work around this with other methods, maybe going to Route 53, for example. Yeah.
Great.
So we have our microservice for users ready. Let's see if this already propagated. Should be almost there. Here we go. So yeah, finally we have the response from our main application responding through the microservices for the user. So we added another branch to our final solution from the microservices, and we have that combination. And over time, we will migrate the rest of the services. So yeah, that completes our demo in AWS.
Well, great. That was very useful. Thank you, Will, and thanks to all for joining us. If you want to explore how to implement solutions such like this in your company, don't hesitate to reach out to us. So, yeah, see you soon. Thank you.
Thanks, everyone.